Okay, so in this video, we're going to have a look at a typical sort of exam question of applying the differentiation that we have learnt so far. So we're asked to find that there's a curve and it crosses the x-axis at A and B, and we're asked to find the coordinates of A and B. So there's no differentiation involved at this. We're literally finding that we've got a curve, some kind of ln of x, and we're trying to find where it crosses the x-axis. So that would mean, where is y equal to 0? So all I'm going to do is put this equal to 0 and solve it. Now, if this is equal to 0, then it means that x squared minus 3, if we like e both sides, is equal to e of 0, but anything to the power of 0 is just 1. So this means that we've got where x squared minus 3 is equal to 1. Well, x squared is then equal to 4, so we get two values for x. We get plus or minus 2 once we square root both sides. We're asked in the question to find the coordinates of A and B. So we need to find the corresponding y values. So when x is equal to 2, y will be equal to the logarithm of 2 squared, which is 4, minus 3. So 4 minus 3 is 1, but log 1 is 0. So our first coordinate will be 2, 0. Now if we put in our other coordinate for part A, when x is equal to minus 2, y will be equal to ln of, well, it's going to be exactly the same, isn't it, if you look at it, ln of minus 2 squared is 4, so log of 1, which is equal to 0. And we expect that because if you go back to the question, it actually just said it's where it crosses the x-axis, it's where y is equal to 0. So we've got 2, 0 and minus 2, 0. Okay, so now we can do part B, which is to have a look at what happens to the normals of A and B where they meet at P. Well, before we can even worry about P, we're going to need to find the normals of A and B. So the first thing we're obviously going to have to do, as soon as you see the word normal or tangent, is we're going to need to differentiate this. So y dashed will be equal to, right, so it's the chain rule, so we need to differentiate ln of anything. Well, differential of ln x is 1 over x. So the differential of ln anything is going to be over the anything. And we then need to multiply by the differential of what's inside the brackets. Well, that's just 2x. So there we go, there's our gradient function. And we want to know what happens when x is equal to 2 and when x is equal to minus 2. So when x is equal to 2, y dashed will be equal to 4 over 4 minus 3, which is 1, so that's just 4. And when x is equal to minus 2, y dashed will be equal to minus 4. Now minus 2 squared minus 3 squared minus 3 is going to be exactly the same as here. We're still going to get 1, so we're just going to get minus 4. So now we know the gradient function at each of these points in order to be able to find the equations. But remember, we're asked for the normals. We don't want to fall for that error. So let's find the equation of the normal at A. So the normal at A, so we're going to have y minus y1 equals mx minus x1. So remember that the coordinates at A are 2, 0. So y1 is always going to be 0, so straight away get y is equal to. Now the gradient of the normal is going to be the gradient of the curve with a change in sign and the reciprocal. So that's going to be minus a quarter x minus 2. Okay, so that's our normal at A, and if we do our normal at B here, B, don't forget, is minus 2, 0. So we're going to get y minus y1, well that's 0, is equal to change of sign and find the reciprocal, so this will be positive a quarter, x minus minus 2, so that becomes plus 2. And now we're asked to find where these meet. They meet at P, so we just need to put them equal to each other and find the x value. So when they're equal to each other, you'll have minus 1 quarter x minus 2 is equal to 1 quarter x plus 2. Let's change pen. So the first thing I'm going to do is multiply by 4. So if I multiply by 4, I'm going to get minus x minus 2, because 4 times 4 is just 1, is equal to x plus 2. Bring it all over to one side and collect like terms. It's going to give me 2x over here is equal to plus 2 minus 2. Well, that's going to be 0. So x is equal to 0. So the coordinates of P will be when x is equal to 0. These guys actually meet on the y-axis. So now all we need to do is find the y value. Now this value lies on both normals. They meet at both points. The x is equal to 0 satisfies both equations. So now we need to find what will the y value be of the normal, because it's where the normals meet. So we just need to plug x is equal to 0 into either of these equations. I'm going to go for this one because it's not got any negatives. So when x is equal to 0, y will be equal to a quarter of 2 quarters, which is just a half. So P will be 0, a half.